Some other minor features that you may want to know about spanning tree as well. Most of these are going to be related to security of the network. These are independent of the mode that you're running spanning tree on. These are just some additional enhancements that Cisco added to make sure you don't have problems in loops in the network or someone trying to do some sort of layer 2 attack on spanning tree. Where the first of them, the BPDU filter feature, this is the equivalent of the passive interface for spanning tree, where it's used to filter spanning tree updates as they go out the interface or as they come in on the interface. The typical case that you would want to do this is that on your edge ports that go onto the end hosts, you don't want to advertise the details of the spanning tree topology to them. So if I know in the network, I know what the root bridge's identifier is, and I know their priority value, if I wanted to take over the spanning tree network, what could I do? You advertise a lower priority. So by running this on the edge, the BPDU filter, it says that if I receive spanning tree inbound, just throw it away. And I'm not going to advertise my information out because there's no reason that the edge of the network should be running the protocol. The only problem with this feature is that if someone has multiple access ports, where let's say at the access layer, you have multiple interfaces that go to, like, let's say a meeting room like us here. So there's multiple physical ports. If someone takes 2 of these interfaces and plugs them into the same switch, if the access layer switch is running the BPDU filter feature, there's nothing stopping the frames from going out and then coming back in, because spanning tree is essentially disabled. A lot of times what the network will run instead then is a feature known as BPDU guard that says that if there's an error in the network, just shut the port down. So if someone connects a switch to the network and they're not supposed to, it's not going to filter, or it's not going to just filter the spanning tree information. It's just going to disable the port so they can't get onto the network. So this would be the more secure version of this. What this is designed to prevent is what's known as a layer 2 man-in-the-middle attack, or an MIM. We're going to talk about some more details of this in security, but one of the variations of this that you can run against the spanning tree topology is that if I have my access layer, so I have some access switch, that there's multiple connections going on to the end users. Then upstream from them, they go to the distribution layer, and then somewhere in the network there's the root of the spanning tree. The idea is that if I'm trying to go from one switch to another, I have to go up towards the root, because that's how the root ports are formed. That's how the tree is formed. That if I have a host A over here trying to reach B over here, the traffic flow is going to look something like this. It has to go up to the root and down. The security risk with this is that if someone takes 2 of these ports and plugs it into their end station, so let's say a PC has multiple NIC cards, if they start advertising with spanning tree that they are the root of the topology, it means your layer 2 traffic pattern changes so that to get from A to B, your traffic has to do this. And this is the goal of the attack, to get the traffic to transit between your 2 interfaces so they can run a packet sniffer. And there's all sorts of different variations of how you can implement this on the LAN. One of them is based on spanning tree. We'll take a look at some other variations. You can do this attack with DHCP. You can do this attack with the address resolution protocol. Or you can do this attack by simply flooding the LAN with multiple MAC addresses, which I mentioned before is like that MAC of attack, where the ultimate goal is to get the traffic to transit between these 2 interfaces, but the end machines aren't going to know this, because the LAN speed is already fast enough that if I'm switching between the interfaces at 100 megabits per second, it's very unlikely that the end application is going to know. So if B is my web server and I'm the client at A, I'm not going to report a problem to anybody because the traffic actually gets there. So from my point of view, everything is fine. It's just that on the LAN, it's moving between these two ports, and then this machine here, whoever the attacker is, they're able to sniff all the packets.
So how's the guard option protect? How does it protect?
Because to be part of the spanning tree topology, the end host would have to be advertising BPDUs. So to prevent this, what you would do is that on this access layer switch, on this port here and this port here, if you ran the BPDU guard feature, as soon as this host tries to advertise spanning tree packets, the switch is automatically going to shut these ports down. So it then just denies them access to the network. This one here, root guard, is similar to that, but this is used typically in cases where a service provider is using Metro Ethernet as transport for a customer, where I'm trying to prevent against a misconfiguration, where I want to make sure that the root port in the network is in my core where it's supposed to be. The way that you would implement this one is that if I have the core where I'm supposed to be the root, then from the core layer you go down to distribution. From the distribution you go down to the access layer. At the very last stop on the access layer, this is where you would put the BPDU BPDU guard. So this is going to prevent your end host from running spanning tree. What it doesn't prevent against is someone plugging another switch in here and then messing up the rest of the topology. So typically what you would also do is on the designated ports facing downstream. So if this is the root, that's going to be its designated port. This is designated. This is designated. On the other side of these are the root ports. On these interfaces, here, 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 and here, we would run the root guard feature. What this says is that it's okay for spanning tree to run on the interface because it's a normal interconnection between the switches. But if someone were to accidentally lower their priority, so let's say they set their priority to 0 and they start advertising themselves as the root bridge, you can disable the port for that specific instance of spanning tree. So it doesn't necessarily take down the entire network. It just says for that instance there's some inconsistency, so I'm not going to forward traffic for that CAM table on that link. So if security of spanning tree is one of the issues, normally you would run these two features in tandem. Where BPDU guard is at the access layer, root guard is going to be on all of the other switches on their designated ports, facing downstream away from the root bridge. This last one here, this is for preventing physical layer 1 problems in the network, which is sometimes called a unidirectional link. And a unidirectional link usually happens when you're running fiber as your physical media. That if I have switch 1 connected to switch 2 over a fiber cable, this is made up of two different portions of the cable. On switch 1, this is its transmit channel. On switch 2, this is receive. This one on switch 2 is transmit. This one is then receive. So I can run in full duplex mode because there's separate physical links that you're using for sending the traffic and for receiving the traffic. The potential problem you could run into, though, is that if I'm able to receive, but this link goes down, the traffic ends up being one way. So switch 1 can receive packets in, but it can't send them out. And the result of this from a spanning tree point of view is that if the root bridge is up here, if switch 2 stops receiving the BPDUs in the interface, what's going to happen? So let's say we're running the original spanning tree where we have the hello interval of 2 seconds, the max age of 20 seconds, and the forward delay of 15 seconds.
It's going to reconvert after 20 seconds.
After 20 seconds, if it doesn't hear a BPDU, it's going to try to transition that state into that port into forwarding. And the problem that you end up in is that this one is forwarding and this one is forwarding, where basically I could say that this is my designated port, but the other side says the same thing. So you cause a one-way loop in the spanning tree network. But the only case that you really get this is that if there's a break in your send channel but not your receive channel. And there's two protocols that are designed to prevent this, LoopGuard and UDLD, or Unidirectional Link Detection. This one here is a function of spanning tree. This one is a separate protocol for links that you're running routing over, not spanning tree, but you still want to prevent this. Where there's a really good write-up on this, if you look for UDLD versus LoopGuard. Spanning tree protocol enhancements using LoopGuard and BPDU skew detection features. Typically, you run both of these at the same time. And this talks about that case where if the link becomes unidirectional, what happens? You end up with two devices forwarding at each other, both as designated ports. But there's certain cases where one of the features prevents this and the other one doesn't. And this is why most of the time you would want to run both of these on your uplinks. Where LoopGuard, it uses spanning tree packets, so it's going to prevent against a software crash of spanning tree. So like if you run into an iOS bug, LoopGuard would be able to fix that. UDLD doesn't do that because UDLD is looking at the layer 1 status of the interface. So this one fixes problems if your wiring is wrong, where LoopGuard fixes problems in the spanning tree process itself. And this is why a lot of times you run both of them at the same time. So this fixes your layer 1 problems. This fixes your spanning tree problems. Even though this would be a really, really rare case that the spanning tree process crashes, it's still potentially possible. And you would cause a layer 2 loop and then potentially bring the rest of the LAN down because of it.
But this phenomenon only happens when you have fiber?
It's possible to happen with copper, but it's pretty unlikely because the pairs are already twisted together. Right. If one of them is broken, it's pretty likely that all of them are broken. But with fiber, it's a common occurrence because there's separate physical cables. So the configurations of these features, they're pretty straightforward. Like for the BPDU filter, you simply go to the interface level and you say spanning tree BPDU filter enable. Or for the BPDU guard, you would say spanning tree guard, or no, spanning tree BPDU guard enable.
So you can enable both on the same port, in the same interface?
This one, BPDU filter and BPDU guard, it wouldn't make sense to run both. You would run one or the other, not both of them.
If you put in the spanning tree BPDU default or BPDU guard default command, does that enable it or disable it?
In global config, you mean?
Yeah.
If you say spanning tree portfast BPDU guard default, this you would run in conjunction with spanning tree portfast default, where this is the easiest way to do it. It's going to protect you automatically, where it says figure out what are the edge ports automatically. And it figures that out based on what? If I don't receive a spanning tree advertisement, I'm going to assume it's an edge port. But then if I do receive an advertisement, shut the port down. This automatically is not on your trunk links because your trunk link normally wouldn't be a portfast interface. The only case it would be port fast is if you're trunking to your end host, like you're trunking to your VMware machine. But normally between the switches, you don't run BPDU guard. That doesn't make sense because you want spanning tree on between the switches. So this is going to prevent the end hosts from having the forwarding delay, but also protect the security of the spanning tree network. Question?
So the port fast default would not turn on the port fast unless this is a host that is connected.
Unless it's a host connected to
But
it,
if
right.
there is another switch, then it will not turn on the port fast. And in that case, the guard option would not help you. If I need to enable also the root guard.
Correct. The root guard you would still want separately from this, where you do that on a per port basis, because you would want root guard on the interfaces that go downstream away from the root bridge. So from the root, when you're pointing down towards the access layer, root guard would go on every outgoing interface. So this interface facing downstream, this interface facing downstream, that's where root guard would be. For BPDU guard and port fast, that's only going to be at the access layer, which is connecting to the end hosts.
The root guard is just preventing an root.
Advertisement, correct. Yeah. So it's kind of a subset. Root guard is a subset of what BPDU guard is doing. This one says if you hear any spanning tree, just shut the port down. This one says if someone else tries to become the root, then shut the port down.
But here's a scenario. So I have this access layer switch, and then I want to actually enable port fast based on demand. If the
Right.
host is connected, enable port fast, but you can also connect another switch.
Right. So if you have the access layer, and this goes down to your end hosts. So these interfaces go to the hosts, but then you're normally going to have other switches that you go to.
Right.
What's one of the key differences between these ports and this port? Assuming you're running layer 2 end-to-end. What type of interface is this? It's a trunk.
A trunk, but you can still use an access port or an edge port to connect another switch. Because it still pass.
You can, but you wouldn't want to do that. If the ports do connect between switches, you don't want port fast on. And that's why it's warning you here that it says if it does connect to a switch, don't run port fast because you can cause a loop with it. So the key is that when you turn these two features on, the switch automatically knows to run it on these ports, but not the trunk, because the trunk is between the switches. So it's looking at not only the BPDUs, but it's looking at the ports mode. So if we were to look at show interfaces status, it knows that I can run the BPDU guard on these ones because these are access ports. But don't run it on that one because you're running spanning tree anyway. It's a trunk port. So the filtering is not on these interfaces unless you manually put it at the port level. So the switch is kind of figuring out the situation for you automatically. That if there's a single VLAN number, it knows that's supposed to go to the end host. But if it's a trunk port, then it's supposed to go between the switches and you should be running spanning tree.
And if you have root guard on one of those trunk interfaces and it senses that somebody else is trying to become or has a lower priority, will it shut itself down or will it shut that other port down? Does it shut itself down, right?
It shuts itself down, right. The way you would see this if we were to look at the, let's say, show spanning tree. Let's say for MST instance 1, this is where our root port is right now. So if I were to go to this interface and say spanning tree guard root, it should almost immediately shut the link down. It says root guard is blocking this now. because that's the interface that I was using to reach the root before. It basically means there's a break in the topology now. There's some hosts that aren't going to be able to reach each other. But it's kind of like you're cutting off some portion of the network to make sure that it doesn't affect the rest of it. If you were to look at this in the documentation, there's a centralized section that talks about these other features if you want to get more information on them. Which again, the documentation is under support. Then all the way at the bottom of this under configure, we would go to products and switches. Then whatever your switch is, let's say core 4500 series, whatever your switch is, the configuration guides, and then for the particular version, like let's say whatever the highest regular iOS release is, let's say 12 to 37. This would be under optional spanning tree features. So it gives a description of what are all these different features and what do they do. Where the rest of the stuff that we talked about would be documented under this configuring STP and MST. Okay, any other questions on anything we talked about today so far with spanning tree? Question?
For root card, is this strictly for spanning tree software failures?
For software failures, right.
What about this misconfiguration? Would they consider it something? What would prevent a configuration error? Let's say you actually had a root. What about the BDU cards and all that stuff enabled?
What it would prevent against if someone accidentally, so let's say switch 1 goes to switch 2. So that's the transmit, this is the receive. The root bridge is somewhere behind switch 1. So the BPDUs normally flow in this direction. If someone were to accidentally configure BPDU filter on this link, LoopGuard on this end should catch it, because that's a misconfiguration, but it would end up in a unidirectional link normally. But mainly it's designed just that if the spanning tree process crashes for some reason, like your utilization goes to 100% and you can't process the packets, then LoopGuard is basically going to shut the link down to make sure that you don't cause a loop.